Okay, welcome. This is Phys2320 Computing 2. This is Functions4. So, in the first three functions videos, we've been looking at how to define and use functions. We've described how you can pass data into a function as a parameter, and how you can get data out of the function using the return statement. We've talked about positional and keyword parameters, and how keyword parameters can have a default value. We've shown how you define a function that looks for a variable number of arguments, parameters, that can either be positional or keyword parameters. And we've also been showing how to call a function using a list or a tuple to supply the positional arguments, or using a dictionary to supply keyword arguments. So in this video we're going to talk a little bit more about what functions actually are and some of the other things you can do with them in Python. So the first thing is to think about when we're actually defining a function in Python code. What we're really doing is we're creating a block of code and we're assigning that to an identifier. So when you do def function, whatever it is, what you're saying is create an identifier, a variable called function, and then assign it the value of this bunch of code. Why is it important to think about this? Well, this allows us to use functions as parameters, so we can pass a function into a function in the same way that we pass other types of variables into functions as parameters. Okay, so we're going to have a quick look at how this might all work. So here's our code that we've been using before. It's calculating a Fibonacci series. So we have our def Fibonacci function, takes a maximum value it's going to calculate up to. It initializes the sequence, and then we have a while loop which says until the last value in the sequence is it's still less than the maximum value we're looking for. Append, and then I've just changed this ever so slightly. What we're now doing is we're having a function called myAdd, which takes the last two terms in the sequence and appends that to the sequence, the seq, and that keeps on going round and round and round until it comes to a big enough term, and then it returns the value of the sequence. And down here we have the function I've created, myAdd, which, as you can see, is very simple. It just adds the two numbers together. And then here's where we're calling the function. We just run it through like this. Okay, so we can go and run this and see it does indeed produce a Fibonacci sequence. Okay, there's nothing different or unusual there. Now in Computing 1 you were introduced to the ID and the type built-in functions that let you look at Python variables. So type tells you what type something is. So if I do type Fibonacci, it tells me it's a function. If I do ID Fibonacci, it gives me a number. That number doesn't mean anything, it's just a number that is unique for this particular function. Now I can treat Fibonacci. Remember, Fibonacci is basically just a variable that happens to have a value that's some code you can run. That means I can assign it to I can assign other variables to be the same thing. So I can have, say, func equals Fibonacci, and I can do type func. It tells me it's a function, and if I do ID func, then you see it's got the same number as when I did ID Fibonacci. So in other words, it's exactly the same function. It's just two names for the same bit of code. And that also means that, for example, I can do func 100 and it produces a Fibonacci series, just the same as if I called the original function. They do exactly the same thing because they're the same function. Okay, and we can do something similar with myAdd as well. Okay, so let's see what we can go and do with this. Well, first of all, I'm going to change this Fibonacci function. So I'm actually going to pass in a parameter called func, and we're going to use it down here. So what this means is that Fibonacci now takes a second parameter called func, and it's going to use it by trying to call it. So func had better be a function, otherwise this is not going to work. So now when I want to run it, I can just change that to add in as the second parameter when I'm calling the function, just my add. Now my add, you see, it's just the name of the function. So the way to read this is I'm calling the function Fibonacci, I'm passing it in two parameters, maxana, which I'm setting to 100, and the parameter func, which I'm setting to be the same thing as my add. So then when I call this, what it's going to go and do, it's going to go through as it was before, but now it's going to go and call, every time it gets here and says, okay, call whatever func is. Well, the way I've called this, I've said func is my add, and it's going to just add the two numbers together. So if we run that, then it does the same as it always did. It calculates the Fibonacci series. But now I can write a different function. Let's see. Here's something that looks like that. So now I've created another function called my square add, and that just adds the sum of the squares of x and y. And then in order to use it, I just go down to where I'm calling it, and rather than telling the Fibonacci function that my func is my add, I'm going to tell it that it's my square add. And there you see it now does the sums of the squares, which obviously gets quicker, much faster than the standard Fibonacci sequence. So in other words, I can replace the function I'm using by passing it a different function in as the parameter. Of course, in practice, what I might want to do is give it some sort of default value in here. So I could just do that like that. However, that's going to give a problem, and we'll see what's going to happen in just a second. So the problem is that when I run the def line here, it's going to try and work out what my add is, but of course my add hasn't been defined yet, and you can see there's a little warning sign here saying undefined name my add. So when I run that, it says, oh no, my add doesn't exist. Of course, there's an easy way around that. I'll just put them the right way round so that my add exists before it gets round to calling it. And there we go, it's all happy again. So you have to be a little bit careful. This is another important point actually in Python, is that when you run Python code, def is a executable statement. That means it's something that Python actually runs. So what happens here is it gets to the def line, it says def Fibonacci, and then it goes through here, and then when you have a keyword argument, because func is a keyword argument because it has a default value, it's actually going to evaluate that result now when we're in the def line. So everything that's on the right hand side of the equal sign better be a valid Python expression when you're actually executing the def line, not when you're calling the function. It's when you're defining the function that this needs to be okay and correct. Okay, so that's just a very simple example of using a function to pass in as a parameter and then using it inside the other function. Why is this useful? Well, there's quite a lot of time we're going to find as we go through, especially looking at some of the SciPy, the scientific Python packages, where you're going to want to pass a function into a parameter, as a parameter into one of the SciPy library functions. So for example, if you're fitting some data, you want to have a fitting function, and the way Python will work is you'll define a fitting function as I've defined square add here, you just define it as a normal Python function, and then you'll pass it into the code that does the fitting and say, use this function. Okay, so that's all well and good. Now what we saw just at the end there is that sometimes it's kind of handy to have just a simple one-line function to do a calculation. I mean, having a complete function to do my-add is a real pain. It's for them it's just adding two numbers together. So there's a way around we can do this. Python has this thing called a lambda keyword that lets us create a strictly a mathematical function. It's called a lambda function, a piece of code that you can assign to a variable, you can use, and the key thing about a lambda function is it has to be something that returns a number. It's a simple mathematical expression. Okay, so let's see how we could use a lambda function in here. Okay, so what I was doing here is I was having my-add as a function here, and then I had to put it in here in order to have it defined before I tried to find the Fibonacci sequence. Maybe a better way around doing this would have been to do it something like this. Okay, so what I've done here, this is the key thing, I've done lambda x, y, colon x plus y. So this is showing you an example of how the lambda keyword is used to define a function. So the basic syntax is you're going to have to create a function out of this, so f, we'll call it f, lambda, and then it takes a list of the parameters that's going to be just without square brackets, just separated by commas. So let's have x, m, and c in this case, then a colon, and then a Python mathematical expression that's the result. So in this case that's just defining something which is basically a straight line. Like so. So if I ask it, well, what is the type of f? It tells me it's a function, because that's what lambda does, it defines a function. And f is just a standard Python identifier, so you can do ID on it and it'll show you the internal ID number for the f function. And I can call it f, so let's have, say, I don't know, 3, 2, 1, so it's going to do 3 times 2 plus 1, which is 7. Okay, so back up to our code here. You see now I've defined the default value of func as this lambda expression. Okay, so now that means if I go and run this code, like so, then it's going to calculate the standard Fibonacci sequence. So what's happened here is when I call it, I pass it just one parameter. So this is I need the default value for func. That's this lambda function. So func now becomes this very simple function that just adds the two numbers together, and that's what it ends up using. But if I pass it a name of another function I've defined as my square add function, then it executes that instead. So in this case I've supplied the func keyword value and it's just going to use the function name to go and call it with. So we're able to very simply go and just get in there and create a function and use a function as a variable. And then also that you've seen how you can easily define a quick function on the fly to go and whenever you just need something which is very quick and simple, and the lambda is a nice convenient way of doing that. Okay. So the other thing I wanted to talk about in this video was another slightly more advanced topic in functions. So what we were seeing both just now and in the first two videos, we were defining functions that made a sequence of numbers, and that's fine, it works well. But sometimes you end up with a situation where you want to make use of that sequence in a loop, and obviously if it's just a nice short sequence, that's no problem. You can calculate the full long sequence of numbers and then loop over them with like a for loop. So, I mean, for example, that's exactly what we're doing here. Our Fibonacci function is creating a sequence, So we end up with a list of numbers here, and then this for loop is just iterating over them, printing each one in turn. The problem is that if you're doing this with a very long sequence of numbers, then this can get a bit of a pain, because it's potentially very slow, because you can't start doing anything with that sequence of numbers until you've actually calculated the whole lot. And the real killer is it uses an awful lot of memory, because you need to keep the whole sequence in memory while you calculate it, and then whilst you use it. Whereas if you think about, especially something like a Fibonacci sequence, in fact, to calculate the Fibonacci sequence, you only ever need to remember 2 numbers at a time, because you only need to remember the last 2 numbers of the sequence. You don't need to remember anything else at all. And so it'd be nicer if we could go and calculate the next term, then print it, calculate the next term, and then print it, and so on. So we can do this. Okay, so here's our code again. This is our code to calculate the Fibonacci sequence. And we're just going to go and change this now so that rather than calculating the entire sequence of code, entire sequence of numbers, and then looping over them, instead we're going to have it go and calculate one term, and then print it, and then the next term, and then print it, and so on. So we need to make some changes to our code. And the main thing we need to go and do is add in here one extra line and take out the return line. Okay, so what we're doing here is we're saying get the list of the numbers we've calculated so far and remove element 0. So in other words, that's going to get rid of the first element from our sequence, and yield means to take that value and pass it back to whatever called the program. The difference from return is that return then says, okay, I've finished with this function, if you need to call it again we're going to start from the beginning, whereas yield is going to say here's a value back from the function, but if I call the function again it's going to pick up from wherever yield left off. So what's going to happen is we're going to go and start off, initialize our sequence, enter this loop, calculate the third term in the sequence. We're going to say here's the first term from the sequence, and then when we call it again it's going to come back here, it's going to say okay, round the loop again, calculate the fourth term in the sequence and give back the second term in the sequence. Call it again, it'll calculate the fifth term, give back the third term, and it'll keep going round and round and around until this while loop finishes, and after that it'll say okay, now I've done, I'm finished. Okay, so we can show this working. If we just run it straight, you see it's calculated it, the sequence of numbers. You see we are missing the last 2 terms that we had previously, so there was an 89 and 144, and it doesn't return those 2 numbers, and we'll show you why that is in just a second. Okay, so what I'm going to do is I'm going to put a breakpoint inside the while loop, and we'll go and run this in the debug mode, and we'll see what it goes and does. Okay, so here we go. Okay, so I'm going to step through the function, so it's going to define the Fibonacci function, it's defining my square add, not that I'm using it. And now we're going to go in, we're starting the for loop, and it says, okay, I'm going to stop here inside the while loop. And if we have a look in the variable window, you see SEQ, our sequence is just 1 and 1. If I step over that, it's added the next term. Yield, okay, so it's going to print, now that's printing the first term. And then we're going to carry on. And we're going around the loop again, and now we're calling it in again. So your sequence is now 1 and 2, because that very first one we just gave back. And it calculates the next term, and it yields, and there we are, we've just printed the 1. And we can carry on again. And we go back inside the while loop. And now it calculates the next one, and so on. There's the print, back to the for loop, back into the sequence, It's now got 3 and 5 in it. Yields 3. So the sequence has now got 5 and 8. Prints it. Goes back to the for loop. Back into the Fibonacci sequence. And so on, and we go round. And if you watch as I keep going through it slowly, then you'll see the sequence over here keeps building up as we go. Oops. And then we run out the end of the program and we disappear into a bit of IPython. Okay, and at which point the debugger says it's had enough and is not going to play ball anymore. So, what we saw there then is that the yield was causing us to go round and round and round. The reason why it stopped too short is that when the while loop finishes, sequence still has 2 more values left to give back. So we need to get rid of those 2 values to complete the loop. So we can very easily do that. We can just do for term in sequence yield term. Okay, so now if we go and run this, there we go, we've gone through, we've started our first term, so we'll just keep going around here. This is still the same, so you can watch the sequence building up in our variable list here as we keep going. 3 and 5 and prints 8 and 13 and prints, next one and prints, okay, we've now got 55 and 89 and prints, and 89 and 144. Right, so now it's going to work out that this term we just calculated is greater than the maximum value we wanted, because this is this 144 here. So now as we go through, it prints, it calls into the Fibonacci function again, and what we're getting now is it's now finished returned none, so it's come out the end of the Fibonacci function. I'll just run it through to the end. Okay, so what happened is that we didn't stop there after the end because we jumped out of the while loop and then we had 2 more iterations where we ran the sequence out. Just to show you that's really what was happening, let's put a breakpoint down there as well. If we run it again, and I'm just going to fast forward through as it calculates the sequence. You can see the SEQ list here is just holding those 2 terms as we're creating it. We're running through 89 and 144, and now you see we've stopped here. So we come out, we print, we go back, we end up back there. SEQ is 89 and 144. Term is 144. We're printing the last one. And now we run out to the end. And eventually we stop. Okay, if we run that not on the debugger, just to show you all the output in one go. Oops. There we go. Run it, and you see it's calculated the whole term as we're expecting. So the difference from previously is that when we used the return statement, we'd have calculated all of that sequence in one go first, and then we would have started printing them, which is fine. But if you'd asked it for all the Fibonacci series up to say, so that's 10 to the 9, that's a billion. This code, so there's quite a few terms there, this code will just go and print each one as it's ready, whereas previously we'd have had to calculate the whole of that sequence first and then go and print it all out. Now actually the Fibonacci sequence grows quite quickly, so it's in fact not too catastrophically bad to wait for that. I'm not sure whether this will work, but we'll find out. Oh, yep, that was quite fast. So that's a rather longer sequence with rather more numbers in it. So again, if we'd had to go and do it in the way with the just had return statements, we had to calculate all of those lines first, remember all of those numbers, and then go and start printing them all. Whereas what we've got here, we'll calculate the first two numbers, and then, well, calculate the first three numbers, prints the first one, then next term print, next term print. So it's more efficient. Okay, so in this video what we've done is we've seen how you can pass a function as a parameter, so that's treating a function just like it's a variable, and actually this is quite an important thing in Python. If you're into your programming languages, then what this means is that functions are what they call first-class objects, and it's one of the things that means that Python can do something called functional programming. That basically means where you can write functions that work with functions. And we've used the lambda keyword to create a function on the fly. And finally at the end I've shown you how you can use yield to create what we call a generator. So this is a function that returns its values bit by bit. And that's useful if you've got to do some operation that's going to take up a lot of memory, or it's going to be very slow and expensive to do a full sequence, but you can start off processing things one bit by one bit by one bit.